Okay, so this is actually problem number 9 from section 3.3, and something very strange comes up in it that we didn't really get a chance to talk about unless you asked about it in class or came in, so I thought I'd throw it up here just so you have a chance to look at it in case you didn't. We're looking for all the maximums and minimums. We're going to use the first derivative test to do this. Looking at the domain, again, it's a polynomial function, so it's unbounded as far as that goes. And so now we can just jump into doing our derivative. So f prime of x is 4x cubed plus 12x squared, and the negative 2 drops off because the constant's derivative is 0. Set it equal to 0 so we can solve. Which means we're going to have to take out the 4x squared from both terms. Because that's the only way we're going to be able to solve this, guys, by factoring. Once I do that, set both those equal to 0. This guy will give us x is 0. This one will give us x is negative 3. So there are our critical numbers. X is 0 and x is negative 3. Now, we do our first derivative test, setting up our sign chart. Negative 3 is on the left, 0 is on the right. And we know at negative 3 and at 0 we had excuse me, we had our two 0 slopes. So now the question is what's happening to the left of negative 3, what's happening between negative 3 and 0, and what's happening to the right of 0. Again, quick trick for this, you're going to square the number every single time, so this will be positive. So the only thing we have to concern ourselves with the signs is if I added 3 to it, would it be positive or negative? So if I go left of negative 3, it'd be a number like negative 4, let's say. Well, negative 4 plus 3 is negative 1. That's negative plus this positive, okay, or times this, which is positive. So we have negative here. Between negative 3 and 0, we have like negative 2. Again, squaring is positive. Negative 2 plus 3 is 1, positive. This becomes positive. And normally what ends up happening is this next region switches signs. It just seems to go back and forth. Well, when I plug a number bigger than 0 in, a positive number, positive squared is positive, positive plus 3 is positive, we get this occurring. So we get this really weird behavior where it does not change its increasing or decreasing behavior, which, if we look at the graph, you can see right at this point, right here, that's what's happening. At 0, okay, right at 0, right around here, at 0, it is not going back down again, it's still turning up. It just levels off for a brief moment, then points upward. So that's why we don't get the switch from positive to negative, is it's not ever decreasing, it's just increasing, leveling, increasing again, which means it's neither a max nor a min, it's just a point. So it's clear to see from the graph that this is a quartic, so it's going to have in behavior going up for both functions, on both to the left and to the right. So this is an absolute minimum, absolute minimum here. So the question just becomes, what's the value? So let's go take a look back at our work. So absolute min, neither. It's just 0 is just a critical number. If we do f of negative 3, negative 3 to the 4th plus 4 times negative 3 cubed minus 2 gives us 81. 27 is 80 plus 28, so negative 108 minus 2. That ends up being negative 29. And so that is our minimum. So absolute or global min of -29 when x equals -3.